Hello, 5th grade, and welcome to week 35 math. Again, today we are going to be just putting all of our math right into the same video. I've gotten some pretty good feedback. If you want to go back to the other way, please ask and we can look into that. But today we're going to be looking at your spiral review 2.4 through 2.6. The first sheet in your packet is a review on two-step multiplication where you're solving a little fish riddle. Why are fish so smart? Well, let's take a look at the second page, which is all about the coordinate plane. Well, what is a coordinate plane? Well, if I take my straight edge and I draw a line up and down, and I draw another line intersecting it side to side, and I put arrows on the end to show me that these lines are going on forever. I just made a coordinate plane. Okay? The x-axis is the side to side. So the line that's side to side, we're going to call x. The line that's up and down, we're going to call y. Notice I used a cursive x and a cursive y. We're going to be using those more and more now. The center where they meet is called the origin. Call it the origin because that's the middle. And now if I have lines going up and lines going down and lines going to the side, they help mark off where I'm talking about. And this week, each line represents the number 1, okay? So if I'm starting at 0, going up, I've got 1, 2, 3, 4. If I'm going down, those are actually negative numbers. 0, -1, -2, -3. When I'm going left and right, to the right is positive. 1, 2, 3. And if I'm going to the left is negative. -1, -2, -3. All right, guys. So what I'm going to be talking about today is now how to know what the name of a place is. If I have a dot that's right here, what is the name of that dot? Well, what I'm going to do is I'm going to see how many places to the right do I have to go to get to that dot. 1, keep going, 2, there it is. How many places up do I have to go to get to that dot? 1, 2, 3. There it is. So it's 2 over 3 up. 2 over 3 up. So when I'm writing the name of this dot, I'm going to put in parentheses 2 over 3 up. Because when I'm talking about a coordinate plane, the first number in the coordinate plane, or in the coordinate pair, that's what those two numbers are, is my x-axis. The second number is my y. So the first number is my x, 2. 1, 2, went 2 over. Second number is my y, 3. 1, 2, 3, I went 3 up. All right, so let's try that again. If I gave you a dot that was right here, where would that be? Well, let's use our straight edge. 1, 2, 3, there it is. 3 over, and 1, 2, 3, 4, there it is. 4 up. 3 over, 4 up. So I'd call that coordinate pair 3 by 4. 1, 2, 3 over, 1, 2, 3, 4 up. All right, very good. And now the next thing you're going to be working on too, along with the coordinate pair, is properly placing a dot on your graph. So if I just gave you these two numbers and I told you 2 by -3, what that means is you're going to go 2 over 1, 2, and then since it's -3, you're going to go 3 down. 1, 2, 3. 2 over, 1, 2, 3 down, 1, 2, 3. Your dot would go right there. 2 over, 3 down. What if I gave you a different coordinate pair? What if I told you -3 by 2? All right, so the exact opposite of what I just told you before. Well, now you're going to go over to -3, 3 over to the left, 1, 2, 3, and go 2 up, 1, 2, right there, 1, 2, 3 to the left, -3, and then 2 up, 1, 2. All right, so what you're finding out is if I have a number where the first number is positive, but the second number is negative, it's going to go into this quadrant. That's just supposed to be a star. But if I have it where the first number is negative, but the second number is positive, it's going to come into this quadrant. If I have a coordinate pair where both numbers are positive, it's going to come into this quadrant. And finally, if I have a coordinate pair where both numbers are negative, it comes into this quadrant. All right. Enough about coordinate pairs. Let's look at the next sheet in our packet, which is all about division. Let's take a look at some division. Last week we did one-step division. Today we're going to do two-step division. 32 divided by 13. And we're still doing the same little chant we talked about last week. Divide, multiply, subtract, and bring down. Say it with me. Divide, multiply, subtract, and bring down. So now I ask myself, can 13 fit inside of 3? No, cover it up. Can 13 fit inside of 32? Yes, it can. How many times? I might have to do a little two-step multiplication on the side. 13 times, let's try it by 2. Say with me, 3 times 2 is 6. 2 times 1 is 2, 26. Does that fit? Yep. Ooh, okay, good. Let's see if it'll fit in there 3 times. 13 times 3. 3 times 3 is 9. 3 times 1 is 3, 39. Up, too big, pop, pop. So it's going to be 2 times. 2 times 13 is 26. Divide, multiply, subtract. 2 subtract 6, can't do that. Borrow, this becomes a 2. This becomes a 12. 12 subtract 6 is 6. 2 subtract 2 is nothing. So what do I get as my answer? I got 2, and I have 6 left over, so I say remainder 6. 2 remainder 6. All right, let's do that again. Use a little bit harder of some numbers, okay? What if I have, I'm actually going to draw it up here so I have a little bit more space. 6,000 454 divided by 86. Okay? First thing I'm going to do is get rid of that comma so it doesn't confuse me. Now what I'm going to do is cover up all but the first number. Can 6 fit in, or can 86 fit inside of 6? No, it's too big. 0. How about 64? No, 64 is still too small. How about 645? Yeah, it can. Now I gotta ask myself, how many times can it fit in there? And so that's where I'm going to actually do some two-step multiplication to guess and check. 6, 4, 5 multiplied by, let's see. Let's try 6 times. We'll see if we get close. 6 times 5 is 30. 6 times 4 is 24. Plus 3 is 27. Carry the 2. 6 times 6 is 36. Plus 2 is 38. Oh, that's a little too big. But did you notice what my error was? I was multiplying 645 by 6. That's not the number I multiply by. I hope you caught that, because that was a big mistake. I should be multiplying by the 86. So let's try it again. Because 86 is the one outside of the box. 6 times 6, 36. Carry the 3. 6 times 8, 48. Plus 3, 51. Ooh, that seems to fit. And I can do a little mental math subtraction and know that, yeah, I'm not going to fit another 86 in there. So let's put 6 up here, and we'll subtract, divide, multiply, subtract. 5, 16. Subtract 5, subtract 6. You can't do that. Borrow. 4 becomes a 3. 5 becomes a 15. 15 subtract 6. 9. 3 subtract 1. 2. 5 subtract 6. 1. Ooh. 1. 29. Uh-oh. That's bigger than 86. That tells me maybe I can actually fit it in there 7 times. So let's back it up. And let's try it 7 times. Let's go back down here and redo our two-step multiplication. Okay, now we're doing some 7s. 7 times 6 is 42. Good. 7 times 8 is 49. Good. Plus 4 is 53. 536. That doesn't seem to be right. I think we may have made an error. Do you see an error? Let's back it up. We made a mistake. Let's try it again. I know 7 times 6 is 42. Okay, I did that part right. What about 7 times 8? Gets me 56. Oh, so I was wrong. I said 49. 56 plus 4 is 60. 602. That seems to look right now. Let's put 7 at the top. Subtract 602. All right. 5 subtract 2, 3. 4 subtract nothing, 4. 6 subtract 6, 0. Now I can move, divide, multiply, subtract, and bring down that 4. 436. Well, I know it's going to be smaller than 7. I know it's going to be smaller than 6. So let's try 5. Let's do a little two-step multiplication to the side. 86 times 5, right? 5 times 6 is 30. Carry the 3. 5 times 8 is 40. Plus 3 is 43. Hey, that's pretty close to 434. Good. Let's put 5 up here. Divide, multiply, subtract. 430 is what I subtract. 4 subtract 0, 4, 3 subtract 3, 0, 4 subtract 4, 0. So I have 75. And what do I do with those leftovers for? Do remainder 4. And as you can see, it's really easy to make a mistake. So what I told the students in class is this. If you show me your work, but you make an error in your answer, you'll only get 1/2 wrong instead of getting the whole problem wrong. You'll still get half credit for showing your work. However, if you don't show your work and you just throw down a wrong answer, that's where you're going to get the full point wrong. Because long division is so tricky, and because it's easy to make a simple mistake, as long as you're showing me your work, you can still get credit just for showing your work. But I need you to show your work. Don't just throw down answers without actually crunching the numbers. All right? So as you can see, it's easy to make a mistake. To go back and fix it is hard. All right. Thanks for sticking to the end. Good luck on your math day today. And please bring any math questions to our Zoom call at 2 o'clock. It's much easier for me to write it out to there instead of explaining it over the phone. Have a good day.